Finish up lesson 30, looking at arithmetic series in this video only. Now, we didn't finish 8b. Let's go ahead and review 8b. So it says find the sum of the first 50 terms of the arithmetic sequence. So I want s sub 50. Again, I want the sum of the first 50 terms, whose first three terms, where a sub n, the sequence, is equal to the set 2, 13 over 4, 9 over 2, dot, dot, dot. Now, the first thing we actually have to do, before I can do anything with actually finding the sum, okay, is find out what the sequence is. I need to know the generic formula A for a sub n, okay? Now, what that means is I'm going to have to know what happens from here to here and from here to here in terms of what am I adding. Well, those numbers do not look pretty. Okay, so the easiest way for me to be able to determine this is actually talk about, well, what was D actually equal to? If I move back to the original front page, D is actually equal to any term minus the previous term. Any term minus the previous term. So why don't I just go ahead and do that? Why don't I do 13 over 4 minus 2? Okay, now you can do this in a calculator, or you can do it the way I'm going to do it here. That's 13 over 4 minus 8 over 4 by making it a common denominator, which gives me 5 over 4. That is what I'm supposed to be adding every single time. Well, I'm not confident with that. Let me check it. If I take 13 over 4 and I add 5 over 4 to it, do I get the 9 halves? Well, this is 18 over 4, and that is 9 halves. So this value here is the D. Okay, this is my common difference. So if that's the case, a sub n is really going to equal to a sub 1 plus n minus 1 times the, common difference. Now, this thing right here, okay, is the generic formula. Let me plug everything in that I have. Well, I can plug in 2. So I have a sub n is equal to 2 plus, I don't know what n is right now, so I'm going to leave it as n. I'm going to go ahead and plug in the 5/4. There's my generic sequence term. Okay. Now let me return to what I'm actually looking for. I'm looking for the sum. The sum of the first 50 terms. So if that's the case, I'm looking for this being equal to s sub 50 is 50 divided by 2 times a sub 1 plus a sub n. Now, do I know what a sub n is? Oh, I'm sorry, a sub 50. Do I know what a sub 50 is? No, not really. Again, I can use this formula, but first I'd have to go back here and actually find out what I'm looking for. Okay, I'm actually looking for in terms of a sub 50. Or I could skip this altogether and use the formula that we solved for before, this one right here. Okay, I know what n is, that's 50. I know what a sub 1 is, that's 2, and I know what D is, that's 5/4. I could plug all that stuff into this formula, or I could just go ahead and continue to use this one here. I'm actually going to continue to use this one here. So, a sub 1 I know is 2. A sub 50, I'm actually going to go ahead and plug 50 in for this thing and go ahead and find it. 2 times 40, sorry, plus 2 plus 49 times 5/4. Okay, I'm going to take this thing in, I'm going to plug it back in up here. So I have 2 plus 2 plus the 49 times 5/4, 50 over 2. And I'm going to go ahead and just very carefully plug this into a calculator appropriately to find out what that number is going to be. Or again, you can do it by hand, which will end up giving me, if I... Yeah, I'm going to go ahead and have this 25 times 4 plus this is going to, I'm just going to leave this for now. And there is a reason for that, you'll see. This here, when I distribute the 25 through, is going to be 100 plus a 25 times a 49 times a 5/4. This thing right here, I'm actually just going to go ahead and multiply through on a calculator, because that's the only real piece that I'm not sure of. So we have 25 times 49, and then I'm going to multiply that by 5 divided by 4, so times 5, and I'm going to divide that thing by 4. Now it's going to give me 100 plus, this is going to be 1531.25, okay? Which is really, and again, that wasn't rounded, so this is okay to do. You can use the fraction, okay? You can go ahead and send that thing to a fraction. But since it's not actually a nasty-looking decimal, it's not rounded at all, you can continue to use this decimal. So this gives me 1631.25. Okay, or whatever, again, the fraction equivalent would be. But that is the answer to 8b, and again, now you understand why I didn't do that in the last video. Okay. The last thing we're going to talk about is the Formula 9 definition and then the arithmetic means. Now, the sum of the first n positive integers, in other words, these sequence, okay, is given by this. So this is another formula, right? Again, it's just another formula of how to deal with things. Well, this formula actually makes sense, okay? And you'll see why. I'll show you here shortly, where the sequence is just, again, 1, 2, 3, 4, all the way up to n. Okay, it's just a consistent sequence of numbers just added to each other. Okay. The arithmetic mean of two numbers is a plus b is equal to this thing. Now, this thing just makes logical sense. Okay, the mean is the average. The average of the two is taking the two numbers, add them together, and divide by the 2. Well, when I ask you to find 3 arithmetic means between 3 and 13, let's go ahead and work through example number 11. I'm going to go ahead and get another piece of paper here. Okay, example number 11 says I want 3 arithmetic means, 3 means between 3 and 13. Well, if that's what I'm looking for, this is the way you should see it. You have a 3, you have 3 means in between that 3 and the 13. Okay? That's what you're looking for. I want to know what those 3 numbers are. If this sequence is consistent in terms of arithmetic, because they did say it must be arithmetic means, okay, then what are those 3 numbers? Well, there's a relatively straightforward way of doing this. I'm going to go ahead and use that first formula, a sub n is equal to a sub 1 plus n minus 1 times d. Okay? Now, the thing that I don't know is d. A sub n is 13. A1 is 3. Wait, what's n? Well, notice this would be my first term, second, third, fourth, and the 5th term. So this is the 5th term minus 1 times d. Now I can go ahead and solve for d. So I'm going to subtract the 3 from both sides. I get 10 is equal to 4 times d. I divide both sides by 4. I get d is equal to 5 halves. That's the number that I'm supposed to be adding every single time. So I'm going to do 3 plus 5 halves. Okay, and that's going to give me that I'm going to have 6 over 2, so it's 11 over 2. That's the first arithmetic mean. Okay, I'm going to add 11 over 2 plus 5 halves again and get 16 over 2, which is really 8. I'm going to add 8 or 16 over 2 plus the 5 halves and get 21 over 2, which is going to be the third one. And I should check this just to make sure. If I add 5 halves to 21 over 2, I get 26 over 2, which is really 13. That does check out. There are my 3 arithmetic means. Those are the answers that I was looking for. Okay, now, let's go back to Formula 9 for a moment. Okay, and actually, overall, we can jump back to the whole idea of the S sub n formula in general. Okay, let's talk about this. If I were to look at example 8a again, and I'm going to look at it in a different light where I'm not using the formula, okay? S sub n, I want to find out what S sub 100 is. The first 100 terms all added together, okay? And I've got this, this sum, the series, okay, of I equals 1 to 100 of 2i minus 1. Now, we already wrote out a few of these terms, okay? It was 1 plus 3 plus 5 plus 7 plus and so on and so forth. The last term, if we recall, when I plugged in 100, I got 199. Okay? That means that the term previous to it would have been 197 and so on and so forth this direction. Okay, now, here's the idea of the formula. The formula is n divided by 2 times a1 plus an. Okay. Now what I'm going to do is something that's very, very tricky. I have a 1 here. I'm going to take the last term, I'm going to put that down here, and I'm going to add that together. That's going to give me 200. What if I took the second to last term, I moved it over here with the 3, and I added that together? So I'm just going to continue this line across. Well, if I added those two together, there's a plus sign that can carry through. I get 200. If I did the next one would have been 195 because I subtract 2 from this. 195 plus 5 is 200. Wait a second. If I go all the way through this and then I get down to here where I move this one over here and this one over here, I get 200 and again another 200. So if I take the series, I rewrite it backwards, and I add up all the terms, aren't I getting the exact same number every single time? And what is that number that I'm getting every single time? Well, that number that I'm getting every single time, the 200, is really the first and the last term added together. Well, how many of those terms do I have? Well, I have starting at 1, going to 100. Now, if I actually count that appropriately, 1, 2, 3, 4, 5, it actually counts logically, so I actually have n equals 100 terms. Okay, so I have 200 coming from the terms added to each other. I have 100 of them. Why am I dividing this thing by 2? Well, think about it. This is the actual series that I wanted. This is a second counting of that series. 100 terms. The last and first term added together is 200. And I want to divide it by 2 because I counted it twice. I counted every single one of these terms twice. That's how that makes sense. So, when I look at formula number 9, the sum of the first n positive integers, s sub n is equal to this thing right here, such that the sequence is this. Now, what I'm giving you is this. I'm giving you that I have a sum of I equals 1 to infinity, or let's just say 100, why the heck not, okay, of just n. That's all that's in there. This is the series that I'm taking and I'm adding up 1 plus 2 plus 3 plus 4 plus all the way up to some number n. Okay, I'm actually going to change this to n. I like that n is better. Okay. If that's the case, then what is this going to be? Well, if we very carefully go through and do the exact same process that I did up here, take the entire sequence, rewrite it backwards. So I'm going to write 1 here, and then over here I'm going to write n. Here I'm going to write n minus 1. Here I'm going to write n minus 2. Here I'm going to write n minus 3, again, because technically I'm going backwards with all these terms. Now, let me zoom that in so you can see it a little bit better again. It's n added to 1, 2 plus n minus 1, 3 plus n minus 2, 4 plus n minus 3. This n plus 1 is n plus 1. That's all it really is. Well, this over here is n plus 1 as well. Notice this right here, if I take and I add n minus 1 plus 2, I get n plus 1. So you'll notice all I have is a bunch of these n plus 1s. How many of them do I have? N of them. So I have n plus 1 times n. But I've counted every single term twice. So I'm going to divide it by 2. That, as you'll notice, is the sequence or series formula in number 9. Okay? That covers lesson 30.